Hey guys, welcome. I'm talking about enzymes today, and the thing to remember about enzymes throughout this video is that enzymes are just large proteins. So basically, the function of enzymes are to speed up reactions. And how do they do this? It's by lowering the energy of activation. So let me define that term for you. Energy of activation. Basically, for a reaction to occur, for example, hydrogen binding to oxygen, leading to something, uh, for this reaction to occur, a certain amount of energy needs to be present or available for this reaction to be completed. And by lowering this energy of activation, enzymes speed up reactions. And in this sense, they kind of act like a catalyst. Next, I want to talk about the substrate. Basically, the chemical that the enzyme works on is called the substrate. So, for example, if the enzyme were to work on hydrogen here, hydrogen would be the substrate. So let's talk a little bit about this substrate enzyme relationship. The word or model that we use to describe this relationship is called the induced fit model. Basically, this model describes how enzymes work. As a substrate enters the active site of an enzyme, or where the enzyme binds to a substrate, let me illustrate that a little bit for you. So let's say this is the enzyme, your active site would be right in there. As a substrate, let's say this is your substrate, comes into the enzyme, that's its active site. As it enters, it induces the enzyme to alter its shape slightly so that it accommodates or the substrate fits better into this enzyme. So basically, this enzyme changes its shape a little bit and allows the substrate to fit better and allows for optimized results. And that's why we call it the induced fit model. Scientists used to call this the lock and key model, but they ditched that terminology because it this lock doesn't change for the key, so this induced fit model is a much better term used to describe this process. So a couple of extra facts to know about enzymes. The first is that they're always reused. They're never degraded in a reaction. Next, their enzymes are usually named after the substrate that they act upon, and usually it's just the name of the substrate followed by the prefix ase. So you'll have sucrase as an example, or lactase as another example. The last thing that I want to talk about is that enzymes function with the assistance of cofactors or coenzymes. So cofactors and coenzymes help enzymes bond to substrates and make the process a little bit easier. The efficiency of the enzyme is affected by temperature and pH. pH. Average human body temperature is around 37 degrees Celsius, and that's optimal for human enzymes. If the body temperature goes above 40 degrees, so 37 degrees is optimal. If it goes above 40 degrees Celsius, enzymes will stop functioning and denature. And when they denature, they lose their unique shape and henceforth their ability to function. As for pH, uh, different types of enzymes require different environments. So gastric enzymes, for example, usually work best in a low pH, while in contrast, intestinal amylase works best in an alkaline environment, which is above pH of 7. But the point is that enzymes have specific environmental requirements that they need to function at an optimal rate.